Hello everyone, I'm J-Max and I'm here to present this video to show you how to build your own Micro Foamboard airplane. So here it is, the Micro Foamboard airplane. It got a 28 inches wingspan, it's a pusher, and the main reason of this design is to be capable of using a wide variety of motors and batteries, being capable of adjusting the balance between the motors and the batteries by moving out the motor pod into the fuselage, and then with a lot of space for small batteries to go from the front to the almost middle of fuselage. It's using simple parts and it's pretty light, very under 250 grams. In that case it is 237 grams with the propeller. On the 2S setup with the 2204 2300 kV motor, just like any mini FliteTest airplane. It is weaker than 2S. It's running like a rocket ship. At least for my skill, it's pretty going on the top of my skill with a lot of throws, I would say, because I kind of like to put a lot of throws into the control surface. But here it is. It is simple. It's kind of easy to build. It's using only 1, 2, 3, 4, 5, 6, 7 parts, I would say, counting the booms, but only 5 parts of foam board. It got a nice characteristic in the air, and I hope you will not find my video too long and too boring because of my accent, but I will show you now how to build this thing and make it fly good. So the first thing you will need to do is to take out your plans on the computer and print them out. When printing, I'm using a kind of cardboard paper to make birthday cards that you can buy at Walmart and Staples, things like that. It's a kind of a very thick paper that is printable, and you just cut around, and no hard step to put the paper on cardboard and then trace it out, cutting it out and stuff like that. You just don't need to stress out. It's directly on the hard, strong paper, easy to trace around. And here's the wing pieces. On the plans I made few markings to show you stuff that I wanted you to be sure to understand, because I don't have the FliteTest color on my plans. I'm not capable of doing that with the program I'm using. So the few things that are important is that it's exactly the same wing as a mini guinea pig with few modifications, but the CG marks are there. Here are 2 marks lying on each side for the booms that will hold the tail together. I will show you that later, but you need to pick out the 2 holes that are right here on the plans through the foam board. This will be your marking to put the 2 booms straight with the wing. After that, you got a double bevel here, just like any FliteTest airplane. 2 creases, a center line to make another creases for the dihedral, and the aileron cuts. And on the aileron, you need to make a single bevel, just like any FliteTest airplane. And I already done that. To make the video shorter, all the pieces have already been prepared. So the center creases, the double bevel for the front, and as any airplanes, if you cut through the paper, just like I did there, you just have to put a small piece of tape and everything will be alright. Then there is the aileron with a single bevel, and the notch in the center for the die drive. One thing is that you need to not make this notch too large because it will affect the wing strength. So just make a small notch and put a barbecue skewer through it, but not forcing it too much because you want to keep the strength of the paper. So just as it is. So I will show you all the other parts and then we go to the assembly. Here there is the main fuselage. So as it is said, it's a B-fold. You need to remove the paper inside the square here, and just like so. And you will need to make B-folds in the assembly and rolled, and I will show you to assemble this thing. But one thing you need to take attention is to mark through the foam board and the dots where you will put the barbecue screw to hold your wing together with some rubber bands. After that we got the spar, and it's just small pieces to make the spar in the wing, and you got a crease in the center to make the die drive, just like so, simple enough. Then we got a hatch for the fuselage. It will be the battery bay for you on the airplanes, and you just need to remove the foam around the periphery of the square there. You got the tail, and one thing you need to take account of is that it's a B-fold, just like on the real piece, but there is a marking line for the elevator, and you really need to pay attention to not cut this part. You need to go on the other side and cut the aileron elevator with the single bevel, just like this. So the B-fold cuts, and then on the other side is the elevator with the single bevel. Just not be mistaken. And then we got the most important piece of this entire assembly, the die draw gauge. Not to miss that part. So here we got our motor pod. It's a B-fold block, so we'll have to remove the foam between each kind of square block, just like the plan says, and that will be holding the motor plates and all the electronic for the airplane. So we'll start out with the wing. We will, as I said, so we'll start out with the wings. So we will start out with the wing. The first thing we will do is put a little bit of glue into the round to make the joint stronger, like to make a hot glue hinges, but you really want to not put too much glue because this is we want to keep the weight as low as possible, so you can have to put less glue as you can. And for that I will just put a small bead on the first the edge of the aileron, just a few 1 or 2 inches maximum, just to make the aileron strong enough, but keeping the weight low. Now we can concentrate ourselves to the folding. I already notches the crease to make sure that they are deep enough and large enough so the fold is going well. But just to make sure that you do the same, just need to put a barbecue screw through the creases and make sure that it's folding well. After that, we can go and try it out to make sure that it's folding well. And since it seems okay, we take the R spar, make sure that we get our creases in the same place as the notch in the upper part of the wing, just like so. And then we can glue that, leaving the center without glue. And don't put too much, because we need to get this thing as light as possible to be a super micro airplane. Once it's dried out or cooling down enough, we can go ahead and put our wing together. And since it's looking good, we'll do as any FliteTest airplane and string it out with this very small bead of glue on the creases. And when I say little, it's a little one. You really want to get the weight as low as possible. Now that it's done, we have to glue together the entire wing, and we'll put a small bit of glue into the corner there, into the double bevel, and put some glue in the spar, but not too much, as the entire, I will say that a lot, we need to keep the weight low, so don't put too much hot glue there. And now we can put a lot of pressure evenly throughout the wing and try to spread the glue a little to make the joint very strong. After that, we get on the other wing, and glue the last part of the wing. So we need to put some pressure down and make sure that this joint is strong enough with a lot of glue, but not too much as usual. So we'll do that. Put a healthy bead of glue, but not too much. And you kind of want to prepare a scrap piece of foam to smear it off the excess glue. So now we can apply some pressure. You want to rock it back to make sure that everything is touching, and you remove the excess part of glue with the scrap piece of foam. Now that it has cooled down enough, we go to make our die draw. So we take our die draw gauge and we want to fold the wing and work it out until we can get our die draw gauge right in the center of the spar, but directly flush with the under of the wing. So we will work it out, not too much, and put the gauge right under there. So that's looking good. We put some glue here. Go back with our gauge. And smear off the excess glue. And wait until it cools down enough that it won't go back. After that, we'll put a nice piece of packing tape around just to make the joint a lot more stronger. Now we got a very strong wing for that little crazy airplane. And we'll put that away for now to concentrate ourselves to the tail. So same thing here as the aileron. With the elevator, I just put a small bit of glue for the first 2 inches and smear it off to make a very good hinges, and that with a lot of crashes it doesn't rip off the paper from the foam. And now we can make the B fold. You will need something square, and as a B fold we want to get the side of the paper of the assembly beside the center plate, just like so, and glue it square with something square. So we put some glue on the inside, just like any FliteTest airplane. And then make it square, just like so. And then what I like to do to make the vertical stabilizer a little more stronger is that I put a small bit of glue inside here, and then I smear off the excess just to make sure it gets strong enough to handle some crashes and rough landing. And we will do the same thing on the other side. After that we go back to our wings and assemble the tail to the wings via some booms. So like I said earlier, I got the 2 holes that I was talking about as a reference mark for the boom assembly, and I make a line between those two dots going down, and it will be a marking to make the two booms straight and together into the wing. So we'll make a small crease with a small cutter through the paper, first layer of paper on the line on each side. And then I would kind of make a crease with a barbecue square. And make it a little larger with the square tip of the barbecue square. And then we go for our booms. Right now I'm using carbon fiber arrows, and it was 20 inches that I cut in two. If you got some carbon fiber arrows and you want to cut them to this 10 inches length, you kind of want to take your knife, a very good one, and make your marks, put the knife on it and roll it with a lot of pressure until it goes down, and start cracking the fiber of the carbon fiber until it breaks free, and then you got two good parts of light carbon fiber booms. But let's say you don't have it, you can easily use a 5/16 wood dowels. It will add a few grams more of weight, but you get you're supposed to have a lot of loose to play with in terms of weight, to be under 250 grams, so it won't be a problem to use 5/16 good quality wood, I will say, of dowels to make the booms. And we'll use our reference mark to glue the booms down, just like so. So we'll start with one, and then we'll put the other one, and you kind of need your square thing to be sure that the booms are straight to the wings. So the first dot I made, it's the reference mark to the tips of the boom. So you want your boom to go as far as the first dot on the wing, but if you got a longer, and you can have a longer boom, like at least 1 inch longer, it doesn't matter, because you can go as far as the front of the wing. But in my case I'm using 10 inches small booms, so I made a reference line for that. And you really want to make that square, so the first thing we'll do is put a small bead of glue there, put the boom down, make it square, wait that's cool down enough, and then we'll put, once it's glued down, we'll put the bead of glue on the side and smear it off to make a very strong joint for the booms. And after that I will go and do the other side the same way, but making sure that we got the same distance between the two booms and that they are straight together, flat onto the tables. So just look at what I do. A small bit there. Now go ahead and do the other side, and by doing so we'll have to make sure that the other side is at the same place as the first one, and we'll put the tip of the boom right on the first dot that I had as a reference mark, and then by doing it we'll go ahead and take a ruler and look that we got at least 8 inches center by center of each boom on each tip of the booms. So we really need to make sure that the two booms are parallel to each other with the ruler, and it's supposed to have 8 inches of distance center to center. And then we go and put the booms flat on the table. Use the table as a frame. It's just to make sure that the booms are straight together. And 8 inches. So now that our two booms are well glued together, we go ahead and take a look to put the tail down into the booms. So what you want to do is to make everything possible to put the tail centered between the two booms. You kinda got some free space to work it, but you do your best, and then you need to put the tail at 4 inches from the back end of the entire wing. So you take your ruler and you put the tail at 4 inches, and you kind of want to put a small mark and do the same on each side. Same thing here. So now we got our two marks. We'll put a small bit of glue on each side and make sure that the tail is in the right place, centered between the booms like that, and align with our marks to 4 inches. After that, just like in the front of the boom, we'll go and put a bit of glue on each side of the bolt and smear off the excess glue, making a very strong joint for the tail, but keeping the weight as low as possible. Now that this have been made, everything is strong, you got enough glue everywhere. It's now time to put the servos on the aileron and the elevator. For this we'll use kind of not new techniques, but some things that you don't see very much on FliteTest airplane, for the elevator at least. And I will show you how to make it. So the first thing we have to do is choose our setup. You can use like 3 5-gram servos if you got some. You could put one on each aileron, maybe in the same fashion as the guinea pig under the wing, and put the wires through the wing and poke it out right in, and put the small servos for the elevator, maybe on the tail, but you can do what I will do with my 9 grams and put a very thin wire of piano wire that goes from the back to the front via the booms inside of a tubing. From there it's your choice. In my case I don't have 5-gram servos, so I'm using 2 standard 9-gram servos, one for the ailerons and one for the elevator. You got some play to go with the weight, so you can use anything you want. You just need to use what you have in hands, and since I got only 9-gram servos, that's what I'm using. For this kind of little plane, just one thing you need to remember is that you need kind of good quality servos, because I had some very cheap 9-gram servos that were very crap and got a lot of loose on it, and they were not working very precisely. And for that kind of very small planes, you don't get too much stuff. You really don't want to get too much slack into the controls and everything, because that will make a huge difference for the controls of the airplane. So try to use some maybe digital servos, or just good quality cheap kind of good quality cheap 9-gram servos. That's good what I got, and that do the jobs. But more precise servos will surely do a very better job for that airplane. So in my setup, I will put the 2 servos centered into the wing joint, and we'll have to put the servos through the wing. So I did not put marks because it depends on your own setup. If you're using 5 grams, use 5 grams and put them everywhere you want. In my case, I'm using 9 grams, and I will put them into the center. And the things that you really want to do is not cut through the spar. So I will put the servos in the front and one in the rear for the elevator, and I just have to make some small notches, in fact holes, to put the servos through until they touch the wings through the thingy here. So that's what we will do. Now that the 2 holes for the servos are made, we can go ahead and put the servos down, and I already removed the small sticker that was there and made some scratch with a knife. For the aileron 1, we'll go ahead and put the wires down and try to put the servo arm as forward as we can to have some loose to play with the aileron, because we kind of have a nice angle of attack. So as forward as we can and as outside as we can with the control arms to have control on the aileron. And same thing for the elevator servos. We put the wires down and kind of try to put the servo arm forward, just like this. So the fit is good. We go and put that a little up, put some glue down, not too much as for the rest of the build. And go down, smear off the excess on the sides, just like so, and do the same things for the rear one. And just to make sure, I like to put some glue under the servos too, since we got access to make everything just a little bit stronger and take a beat up just a little more. So some little glue and smear off the excess with a small piece of scrap foam. Just like so. Now we have to make sure that the servos are centered, and then we'll go ahead and put the control arms down and make our connection with the wires. As you can see, there is kind of a bit of angle on those control arms, but we need to record that with a very steep angle, to record to the servos. So probably that with 5-gram servos it would be a lot simpler just to put the servos down the wing here or under it with a straight line. But since this is what I got, I'm using kind of thicker wires to make sure that there is no friction between the servos and the surface. So it's 1.5 millimeter piano wires, I think. But for the elevator, I will be using a very smaller, like 1 millimeter piano wires, and I will take a piece of coffee sticks, the ones that got some 3 holes in it, just like so, and I will cut it in two to make some tubing that I will tape down into the booms, pass the piano wires through, and make it a nice and beautiful curve, just like so. So just to show you, you kind of have to cut this thing. You need to cut this thing in two. So I will take a knife, pay attention to your fingers, and cut it in 2 halves. So you will get a nice tubing just like that, and we can go ahead and put them together with the wires. So first thing, I will remove this piece of paper, put the Z-bend on that end. So take a pair of pliers. So now that's a modified Z-bend, and that's a normal Z-bend, almost. That would go to the elevator end. On the other end, we put our tubing through. Just like so. Take the airplane forward, put the Z-bend through it, and for the throws you kind of want to follow the normal FliteTest recommended stuff, like 12 degrees and something like that. I kind of like to go crazy all the time, so I will go ahead and do whatever it feels like. But if you're not that good of a pilot, I mean that it's a very small plane, hard to see in the air, and very fast and quick, and so easy to lose control of it. So maybe you want to put low rates and some things that goes smoother if you're not used to it, and then you can crank it up all the way to almost a 3D airplane. So that's your choice. The tubing is kind of too long. If you follow the curves, we kind of see that we need to remove at least 2 inches. So that's what I would do. You want to have at least a 3/4 inch to the elevator to get enough loose to make it move, just like so. So I think I will remove. No, that looks pretty right. I will kind of remove a little more. Just be sure that I got enough throws for myself. Yeah. Now we'll tape down the end to kind of get the tubing into shape, and then we'll see where the wires goes and make a mark for the next Z-bend. So let ourselves at least 3/4 inch. Put tape down in the middle like that. We'll put another one there. And then it's supposed to look like that. Like I said earlier, if you make a mark and you put your Z-bend and you finally end up an eighth of an inch to the other side of it, it's not that bad, because you can adjust the length of the wire just by moving the tubing in. So when we make our Z-bend, and then we'll be capable of adjusting everything up with that thing. So you got your modified Z-bend. You try to put it straight to make a normal Z-bend, just like so. Put your control arm, pass it through. If I can get the freaking thing down, the holes, yeah, just like that. So now, as you can see, we can adjust the center of our aileron elevator just by adjusting this thing here, the tubing. So what we will do is to make some marks, make a small creases, and then glue it down into places. So what I like to do is to plug the servos into place with a receiver connected, just to be sure that it's centered when you do your stuff, when you do glue the things, and that's a trick I have for everything. So in that way you make sure that your servos is always in the center, just like it's supposed to, because when working it's easy to change the controller of places. Well, yeah. Just like so. Maybe a little too much throws. Get one hose down at least. Yeah. That much throws is kind of crazy if you're not used to it. So don't go crazy if you don't think you have the skill for it. And now we put a good bead of glue down and put the tubing there. So what I like to do is to put a bit of glue over the tubing and smear off the excess glue, just to make sure that the tubing stays down as much as possible. And after that we kind of want to reinforce the joint right where the tubing ends, just to make sure that it doesn't move too much. Between the two pieces of tubing I had, you need to make sure that those two pieces doesn't move, just to make sure that you don't get too much loose into the piano wires, and you kind of want to reinforce everything down with tape or glue from the servos to the control surface. When you're sure that everything is strong enough for the tubing, just have to make sure that there is no piano wires moving too much sidewards where you can get some kind of loose. So you make it move enough to be sure that everything's working out. And then we can go on to the ailerons. So as I said earlier, you kind of want to use a thicker piece of wire, and then go ahead and make you join. So here it is. I just finished to fit the piano wires to the servos. As you can see, I just put a large servo arm to the control arms with a kind of thicker piano wires to avoid have some bend. It's a little bit heavier, but just to make sure that you don't get flappy at all. I know that the angle of the piano wires is kind of weird, but it's doing the job. And for the throws, I really recommend you to use the normal throw gauge from FliteTest, because this thing is kind of very quick and agile, but since I kind of like it, I just put as much throws as I can, because I like it crazy a little. But to do what you want, you just have to make sure that you are comfortable with your skill, and when you try this, because it's so small, it's kind of wicked. And since that part is over, we'll go ahead and build the fuselage together with the rest of the electronics. So for the fuselage, we want to make a B-fold like it says in those plans, and just like it's assembled just like any FliteTest airplane, let's say the teeny turner. So you kind of want to put the glue inside until the end of the paper and make your B-fold besides the bottom plate, and make sure that everything is straight with the corner things. On the two sides have been glued down. We want to make the nose part, and we want to work it out with our fingers, just to make the bend and roll around with your fingers, just to follow the curve. Just like so. So when the bend is kind of good enough, we will glue the bottom bar first on just to the end of the rounded tips right here, and then we'll glue a second step on that have cooled down enough to glue the upper part of the fuselage. So small bead of glue in the center there, and on the edge there, all the way to roughly the tips of the fuselage. And then, just like somebody says, use the table as your frame and rock the entire fuselage to make the bend on the foam board. Whoops. Making sure not to glue everything down to the table. After that, we can go ahead and do the upper part. Use the same thing, bead of glue, and use the table as a frame. And on that part, you kind of want to put the LT amount of glue to make the joint stronger as much as possible, because that will be the part that will take the hits when crashing down. After that, we'll glue that little tabs that will be a big reinforcement for that front part of the fuselage. So as the rest of the fuselage, it's a B-fold, but you really need to pay attention to not put too much glue to have an excess on the inside, because there will be another part sliding right inside here. So nice little tab of glue, same thing here, and using a scrap piece of foam to not burn our fingers. And making sure that there is not too much glue inside to block our motherboard. Just like so. After that, we will do the hatch. So there is a nice tab of paper there. So that's where there will be the hinges. And as you can see, there is a little bit of, it's made to be tight, but maybe not that much tight. So we need to work it out with the knife a little. Just like so. So we put some glue on the tab of paper, and with a scrap piece of foam to not burn our finger, we put that down right here, and just smear off the glue forward. And making sure that the hinge is working out. Once that have cooled down enough, we put a bead of glue and smear it off just to make a strong hinge. Making sure that the hatch is closing well. We'll go ahead and make our motor pods. Put that away. So, as the plan says, the center part is the bottom right here, and you need to make a B-fold on the side of this center part. Make everything straight with a corner, and then make sure that this motherboard is very straight, and we'll glue that down together. So this is the front part and this is the rear part, and what we will need to do is to put a nice standard FliteTest mini motor plate at the back of this thing, just like so, keeping the net for the wires on the upper part to make sure that we can pass the motor wires inside of it. And let it cool down enough so that the plates stick well together. Since that plane is a pusher, there is no thrust angle on the motors because you don't really need to. And once the glue is cooled down enough, we'll put some tape all around just to make the motor plates strong enough to hold any impacts. You don't need to go all the way down, but down enough that it will be strong with the foam board. So the motor part done, we go ahead and put the motor electronics inside. As I said in the beginning, these airplanes can use a wide variety of small motors. In my case, I'm using 2204 2300 kV motors with a 12 amp ESC, but can use easily something smaller like 1804, I think, or something very small. And the smaller the motor is, the easier it will be to balance the airplane out, because since the motor is at the rear, you just need the battery to balance the plane out, and the smaller the motor, smaller the battery you will need, and lighter the airplane will be. But in my case, since I got those mini scale motors, that's what I will be using. As you can see, I pre-soldered the wires, and I make sure that the motor was spinning the right way for a pusher airplane. And we take a look to make sure that everything is going down well. So when screwing down the motors, don't forget to put some Loctite, just to make sure that anything is going to lose with the vibration. Okay, so after that we glue the ESC just over there on the bottom of this thing, just to have enough loose for the battery wires and for the receiver. So we just put the wires through the holes there. Just like so. And put a small bit of glue just to make sure that everything is quite tight and doesn't move around. And the excess wires, just roll that down to the bottom. Just like so. So the motherboard is done. I need to try that inside of the fuselage. Fasten the wire through. Just like so. When you will be balancing out the airplanes, depending on your choice of motors and batteries, you maybe will need to maybe you will need to play with the balance a little, and to do so you can play with your motor pods just to put it forward or backwards. Since in my case I'm using 1100 2S batteries that are quite heavy for maybe this plane, I kinda need to put the motor pods just a little in the back, more in the back than it's supposed to. But let's say that you're using a very light batteries with a big motor, but not big motors, but a motor of this side. You maybe want to put the motor pod more inside, and you can put it as inside as the blade is passing. You got a little play to play with for the balancing. In my case, this is just a little bit out, 1/16 at least, just like so. You need to make sure that the power pod and the fuselage are quite straight here, and then you can go with the barbecue screw and poke the holes through everything. But since we put some packing tape through the motor pod, we kinda need to use the piano wires to pull the tape out on each side, just to help a little bit. And pay attention to your motor wires. Just like so. And you want to have at least an half of an inch on each side. Just like that. Maybe a little more, just like we want. And same thing for the front holes. Pay attention to the wires from the ESCs. Just like that. So after that, I will take the wings and put everything together. To do so, we need to pass the servo wires through the holes inside of here. Go around just like so, just to get enough tension for the thing to work. After that, we can need to make the rubber band and the wing as straight as possible on the fuselage, just like so. After that, we can put the receiver down, just to connect everything. One thing I should have done is to put a small tape on the leads that gets the motors, ESCs, and I think that is this one. We'll have to check, but pretty sure it's that one. Connect that to the receiver. And we will see what it looks like. Okay, that is working. So just mark the several leads that go to the ESCs, and then just find out who is the elevator and the other one. That's the elevator, and that would be the other one. Sure that, yeah, just like so. So now we put that aside. As I said earlier, I am using 1100 2S batteries, and that kind of pretty heavy. You can really see where it's balanced out, but you're supposed to be capable and easily to put a 800 2S in right in the front of the nose and balance this thing out easily. In my case, since this battery is pretty heavy, I have to put it as back as I can, just like so, and put the receiver just in front of it, and we'll see how it's going to balance out. So roughly perfect. So now that we know where the battery will go, we can put a small piece of Velcro to put the batteries right in its place. Just like so. So we'll do a recheck. Put the battery down as forward as back as we can. Just like so. We'll put the receiver down, all the wires, as much as we can, as good as we can. Put an antenna down to the left and one down there, just like so. And that's a little bit nosy. And for that airplane, you really want to make the planes very straight, just no nose heavy or tail heavy, because if you get just a little bit nose heavy, the plane will kind of go down all the time, and if you tail heavy, it will be uncontrollable. The thing is that it's so light that you don't have a lot of play to kind of get the plane flight straight. You really need to be on touch, really on the very edge of the CG, just to make sure that it's right. So that is far too much. If you need to adjust that, as I said, you can play with the motor pod, and I will make it the back just an eighth of an inch more, just to make sure that it's balanced out pretty well. So just like I said, I put the motors back of that distance because of the bigger batteries I have, and now it's balancing pretty right. That's what you want to do. Just a little, very in the middle, just not too much in the front, because if it were like that, let's say, it would be a pain in the ass to fly. But just like this, yeah, just like this, that's exactly what you want. But now we need to make sure that everything is good. Elevator, aileron, motor, it's spinning the right way. Everything's good. We just need to weight this thing. So just to show you that it's really the flying weight, I got my batteries here. It's connected. Everything is working. I will put that down. Close the hatch. What I like to do is to put another piece of rubber bands just to hold the hatch, because You can do kind of a small tape latch just to hold the hatch down, but with uses and a little bit of dirt, it starts easily to rip off and blow off in the wind. So the strongest way and the easiest way to hold the hatch down is to put a small rubber band around the fuselage. So just whoop, there's nothing out of the airplanes, just of the props, but I don't put it for security reason. And then we'll put the scale down. It's marking in grams, and plus the props, and I don't know if you can see, but it is marking 237 grams, and it can be more or less heavier or a lot lighter with the smaller batteries. Put down like a 800 2S, put all the way up in the nose, and even you can go with a smaller motor pack and play with it with the motor pod, and that gives you a lot of enough play just to go and do some things like that.